in simplex method. So without understanding the simplex, these points, then it might be very difficult for you to continue to proceed on. So to make you understand how simplex works, okay, or how simplex create the forms from so-called the worst table to the last table, we have to understand the following points, okay, the following standard of simplex method. Just to remind you, the simplex method is mainly focused on solving ADPP by hand, okay, by hand, calculation by hand, in the sense we have to formulate the table so that we can attain or we can reach the optimum solution. Okay, we can reach the optimum solution. So let me share you the important points here. So theory of simplex method. Now, these are the standard form of ADPP for applying simplex method. As I say, you can take a note of important points, but to me, all things are important in this presentation, okay, which you see in front of you, all right? So these are the criteria which we use to form what? Which we are going to use to form the ADPP, okay? Number one, we have something called all constraints should be positive, should be converted into equations except the non-negativity. You get it? If you have the constraints, and those constraints, in order to make or to calculate the optimum solution, we need to convert them into equations. So to convert them into equations, what do? We have to add or subtract the extra variables. Example, we have example of the constraint. This is the example of our constraint. As you can see, here it is. We have a 3x1 minus 2x2. x1 plus 2x2, which is lesser than or equal to what? It's lesser than or equal to 4. And we have the constraints, the non-negativity constraint, which are x1 greater than 0, x2 greater than 0. So this is like a solution, starting solution starting here, okay? You can write here as a solution. What is a solution? Convert above example into equation by adding or subtracting extra variables. Okay? Here we have added the plus S1 plus S2. Okay? And the non-negativity should always be non-negativity. X should be greater or equal to 0. S1, S2 should be greater or equal to 0. Here to remind you, the number of extra variables to be added, they should always be equal to the number of the constraint we have in a problem. Example. Here we have a constraint 1, constraint number 2. Okay. Let's say we have a constraint number 3. Constraint number 3. Let constraint number 3 be x2, only x2. Okay, is greater than, is lesser than or equal to 2. You get it? So now we have a 3 constraints. So the extra variables to add will be 3. Each one will be for constraint 1, which is this one. Constraint number 2, we take S2. This constraint number 3 will also take what? x2 plus s3, okay, which is equal to 2. Okay? It will also be added to the no negativity. Here we had x1 greater than 0, x2 greater than 0, s1 greater than 0, s2 greater than 0, and s3, okay, greater than or equal to 0. Clear? So this is the first point or first criteria to understand. Point number 2. If the sign is lesser than or equal to, then the extra variables should be added to the left-hand side of the sign. I repeat, if the sign is lesser than or equal to, then the extra variables should be added to the left-hand side. Because there are two things. What are those two things? We can add or we can subtract extra variables. So the added variables is called slack variable. This is a slack variable. Look at this example. 3x1 minus 2x2, okay, they are lesser than or equal to 12. This is a constraint. Okay? Solution is 3x1 minus 2x2 plus x1 should be equal to 12. Why? Because the sign is lesser than. So when the sign is lesser than, what do? We have to add extra variables to the left side of the sign. Okay? Where is the left side of the sign? This is left. This is left. This is the sign. This is right side. Okay? So the extra variables will be added to this side. If I take plus s. Okay? It will be added to convert a constraint into into equation. This is inequality. In the first one is inequality. In the solution is going to be what? It's going to be a solution or to start to solve the problem. I hope, is it clear to you all? Is there anyone who don't understand at this point? Anybody? Okay. Nobody. Okay, all of you understand. Good. Good. Now, the third point. If the sign is greater than or equal to, then the extra variables should be subtracted to the left-hand side of the sign. The extra variables is called surplus variable. Underline this one. Remember, when extra variables is added, that is known as slack variable. Why? Because the sign is lesser than or equal to. So when you are going to convert inequality into equality, then we have to add the extra variables called slack variable. Clear? Point number 3, it says, when the sign is greater than or equal to, then the extra variables should be subtracted to the left-hand side of the sign. So that is known as surplus variable. I hope all of you understand what does it mean surplus. I hope all of you understand what does it mean slack variable. Very simple, like drinking water, okay? So look to this example. 3x1 minus 2x2 greater than or equal to 12. This is a constraint or a problem. So to start to solve in a simplex method, you choose which side is a greater or which side is lesser. Okay? When you find that the sign is a greater, like this sign which you see here, then what do? You subtract. The extra variable should be a subtract. This subtraction variable is known as what? It's known as surplus. Okay? It's a surplus. I hope it's clear. Next point. The right-hand side of the sign means, look here, if I took like 2x1, okay, is lesser is than or equal to 2. Okay? This is the left side. This is a left. Please, left side of the sign. Okay? And this is the right side of the sign. Please note it down. Okay? Note it down. So, point number 4 says, if the right-hand side of the sign should always be positive. If not the case, which case? If not the right side of the sign is positive, means it is negative, then we have to convert it into a positive side. By what? By multiplying minus to both sides, left and right side. You get it? Look this example, you understand. 3x1 minus 2x2 lesser than or equal to minus 6. You see here, minus 6 is at the right hand of the sign. And on the top of that, it is a negative side. Okay? What do we do? Number 1. Remember rule number 1. Okay? The rule number 1. Is it rule number 1? Rule number 2. This is rule number 2. If the sign is greater than or equal to, then we have to add. Okay? Here we added to convert inequality into equality. After adding, we have to multiply by minus 1 in order to convert the right side into positive. This is what we did. Minus 1 into or multiply 3x1 minus 2x2 plus s1 equal to minus 2. Sorry, minus 6. So the answer is going to give minus 3x1 plus 2x2 minus s1 equal to 6. You see, we convert the right side into positive because the rules say that it should always be a positive. You get it? So these are the important points to understand when you want to formulate a simplex method table or optimum solution to find optimal solution. Okay? Another important point to note. Okay, these points are also very important. It says, for all maximization, what does it mean? It means that if objective function is to be maximized, then the optimum solution is attained when all Cj minus Zj are lesser than or equal to 0. What does it mean? Example. We can take example here. You can write example here. You can take example. Okay. This example, we say, let's say Cj minus Zj, okay, is equal to minus 2. Okay. Again, you can say this is equal to 0. It is equal to minus 7. As you can see, When you reach to this part, where the Cj minus Zj it's lesser than or equal to 0, then those Zj means the Zj is going to be your optimal solution, and you have to look the so-called the basic variables which are there in your table, as we have seen in example. We shall also see again in one of the example. Okay, this is what is mean. Important point. Okay, for all minimization, this for all maximization means what? Means when you have max z, okay, let's say max z is equal to 2x1 plus 3x2. Okay, 3x2. As you can see, this is the max z. Okay, this is max z, which means we want to find the maximum profit. All right. Okay. The next one. The next one. For all, minimization means if the objective function is to be minimized, then the optimum solution is attained when all Cj minus Zj they are greater than or equal to 0. Means if Cj, what is the Cj minus Zj? Okay, minus Zj equal to 7, comma 0, comma 1, comma 3. At this moment, we know that the minimum cost is being attained. In case you find a Cj equal to Zj, okay? I mean, Cj minus Zj is equal to minus 2, comma 2, comma 0, comma 8. What do you do? You have to continue until you remove the negative. Same case in maximization. If you find one of the Cj minus Zj is a positive, then you have to continue until you have the condition, until our condition is satisfied. Which condition? Zj minus, Cj minus Zj should always be lesser than or equal to 0. Okay, for both sides, for both cases. Clear? Is anybody who don't understand this one? I try to make it, to emphasize this so that you can understand when we start the table format again. Right? Is there anyone who has a doubt or a question? Anyone? I give you 10 seconds. If you have a question or a doubt or something to ask, then you can. Okay. All right.
Excuse me, sir.
Yes, please.
Sir, in the previous sum maximization, we got Cj minus Zj was all were greater than 0.
Yes, that's what we want to do. If all were greater than 0, then we have to continue. You have to proceed the table. We have to enter the row and remove the column, like that. That's why you can have even more than 5 iterations. Means 5 tables which are removing Cj minus Zj. Okay, I will give you an example. To the example which I gave you, I think I have solved it till the last. I told you to check Cj minus Zj for the last table. Did you do? You didn't respond. I gave you that one, you did not respond. So I don't know why. I don't know why you did not respond. So that was the last stage for those who were in the class in the follow. All right? So I'm going to give you a simple exercise. Okay, simple exercise. We are going to solve it, and then you understand. Right after, I will do one more exercise with the three constraints. Okay, and I will give you also a work to be done. So if anyone has a question? Good. Okay, fine. As you remember, where did we stop? Okay, let me give you an example based on what we have learned. So we want to solve LPP. Want to solve LPP, okay? By using what? By using a simplex method. By using a simplex method. A simplex method. Okay. We have a max Z. Max Z is equal to 2x1 plus 6x2. Okay. It's subject to constraint. Subject to constraint. We have x1 plus x2 lesser than or equal to 2. Here we have 2x1. No, let me take only one. I will take only one, no problem. Just to make you understand how it works. Let me say x2 is lesser than 1. Let me say x1 minus x2. Okay? Where x1, comma x2 should be greater than or 0. Okay? So we want to solve this equation. What do we do first? What is the first step? What is the first step for us? What is the solution? I go here. We do this one. We say solution. You can dictate me. What do we do first? Just want to go with you. What do we do first?
Add the slack variable.
Yes. Why? Because the sign is what? The signs are positive. I mean, are lesser than. Okay? If the sign was greater than, let me include this one. I'm going to include both. Don't be confused. Okay, don't be confused or take it in the wrong turn. I want to solve both cases so you can understand. All right? So, let me take x2, like this one. x2 is greater than 5 than 3 minus x2 minus x1 is lesser than or equal to minus 2. You get it now? I'll try to combine whatever we have seen in the rules so you can understand all in the same exercise. Okay? So what do we do first? We want to convert inequality into equality. 1 second. Okay, so we are going to convert what? We are going to convert this inequality into equality right here. convert what? Inequality convert inequality, no problem. So to convert this inequality, what to do? We are going to add or subtract extra variables based on our sign, based on the sign. Remember here, x1, comma, x2 should be greater than 0. So first constant, we are going to do x1 plus x2, okay, plus s1, okay, is equal to 2. Clear? Extra variables, I'm going to write them as what? As a different, color so you can understand. We want to convert them, okay? Plus S1, okay? For the second equation, what do we have for the second equation? Second equation, we have x1 minus x2, okay, plus what? S2. Why? Plus S2. Why? Because the sign is greater than, is lesser than, okay? Is lesser than 1, is equal to 1, okay? Now, third constraint. What do you do for the third constraint? Please tell me. Ashish, what do you do for the third constraint? X2? Ashish, X2?
x2 minus s3.
Good. X2 minus what? S3. Because they keep growing. Okay, we keep increasing this iteration of S, okay, which is equal to, what is equal to 3? Okay, is equal to 3. Now, what is next? What is the constant number 4? Surya is there, or Mona Nandi? Mona? Yeah, Mona is there.
Yes, sir.
Yes, what to do for the fourth constant?
Minus x1
Okay, she said minus x1
plus plus s4, sir.
plus
S4
S4, good, is equal to
minus 2.
minus 2. Then, done?
Yes, sir.
Okay, Pretty V, continue. Pretty V. Pretty V, continue. Where is Pretty V? Yeah, she's there. Yes, Pretty V, what to do? Yes.
Max z is equal to 2x1 plus 6x2.
Before we reach there, Mona, she gave this one, but look, what is this? Minus 2. Okay, Mona. When it is minus 2, we have to multiply by minus 1 to convert into a positive. You get it? So that's why what Mona has said, you have to multiply by what? By minus 1. Minus 1 multiply this one. Okay? So this is going to give us 1. It's going to give us x1 minus S4 is equal to 2. You get it? So this is important to understand. Okay, Mona? Okay, Pretty V? All right? So once we convert like this one, then what Pretty V is going to say is the next step. Okay? What is that, Pretty V? Max Z is equal to? Let me write here. The max Z is equal to 2x1 plus 6x2, correct? Plus what? 0 S1 plus 0 S2 okay? When t comes here, we minus, okay? We minus because it's a subtract, okay? We say minus 0, S3, okay? What about this one? Plus, going to be plus, right? Yeah. No, the sign is minus. Minus S4. No, the sign was a plus here. Okay, we do plus. So plus 0 S4. 0 S4. Okay, 0 S4. Sorry. S4 here. Okay? So once we've done this one, what do? We have to write our equation into table format. We are going to write them into table format. All right? So I'm going to write in the table format. Then when the time permits for the second time, then we shall solve, we shall find ZJ. I will give you as an assignment for the remaining time, so you can find ZJ, CJ minus ZJ, and you continue. Because you have seen, if you have any doubt, feel free to contact me on to check on our YouTube channel for the previous class. All right, so let's plot this one into the table. Please note down this one and dictate me when I'm going to write into the table. Let me give you 30 seconds. For those who are joining late, please take a review of what you have seen. So that you can follow, you can know where we have stopped from and where we started from. Okay, fine. Let me now come to the so-called initial table. The second stage, we go to the initial table. Initial table. We form the initial table. Okay. In this initial table, what do we have? Initial table, we have the so-called CJ. Okay. CJ is a coefficient of Z. Okay. The coefficient of Z are what? Look here. Our converted max Z is what? Let me write here. Dictate me. What Z have you seen? Z. What is max Z? Let me write here. Max Z. What was that one? 2x1 plus 6x2, okay, plus 0 s1 plus 0 s2. Okay, the other one was surplus. We minus, is it minus? 0 s3 plus, and the last one was 0 what? S4. Correct or wrong? All right, so we shall see. So this is how we're going to solve. Okay? No matter it's going to be or are going to be what? Are going to be the zeros. They're going to be the zeros. Right? So here we have 2, 6, 0, 0, and 0. We have 3 zeros. 1, 2, 4 zeros. And 0. Because we have a 4 constraint. Next, here we have something called the basis. Okay, the second is going to be the basis. These bases are known as the basic variables. This is a basis. Remember, Cj is what? What is the Cj? What is the Cj? Cj is what? Cj is coefficient of z. Okay? So the basis which we have, basis variable, we have x1, we have x2, we have s1, we have s2, we have s3, and then we have s4. Okay, we have s4. Correct? Now, here we have another which is called CBJ. CBJ means what? Okay. This is the CBJ. CBJ. CBJ, 1 second. The CBJ is the coefficient of a basic variable. At initial, the coefficient of basic variable is 0. Okay? Now, what are the basis variable? The basic variables, they are the extra variables which you have added. Okay? Which are what? S1, sorry, S1, S2, S3, and S4. Okay? And S4. Clear? Now, what are the coefficient of this one? What are the coefficient of this one? The coefficient of this one are the zeros at initial. Okay? You have them as a 0 for S1, 0 for S2, 0 for S4, S3, sorry, 0 for S4. Okay? Now, what are the coefficient of x1 in our constraint? Look here. Look, we have 1, 1. Here in the third constraint, we don't have x1. In the fourth constraint, we have x1. So what are the coefficient? Coefficient are these numbers which are front here. For example, this is 1. This is 1. Okay. This is also 1. Okay? 1. So what do we have? For the first constraint, x1 is equal to 1. Okay? For the second constraint, x1 is equal to 1, the coefficient. The third constraint, it is not there, so it's a 0. For the fourth constraint, we have it, it is 1. It was a minus 1, but when we multiply by minus 1, it has become 1. Clear? What about constraint of coefficient of x2? Okay? In the first question, it's 1. Second equation is minus 1. Okay? Third equation, it is 1. Fourth equation is 0. We don't have it. Okay? What about in the first constraint, do we have S1? Look here. Look where you have written. Yes, we have S1, which is equal to 1. Here there is 1. It's like there is 1. Okay? We have 1. The rest are zeros. Here we have 1. The rest are 0. We don't have S2. We don't have S3. We don't have S4. Second, for this is 0. We have S2. 1, 0, 0. For the third equation, we have a 0. We have a 0. We have a, we have 1 because we have the S3. And this is we have what? 0. Let me come back to look third equation. Look at the third equation. We have minus, so it's supposed to be minus 1, not 1. It has to be minus 1. Coefficient is minus 1. For the fourth one, this is 0, 0, 0, And what is the coefficient for this? For S, for this S is what? Minus, right? We have minus. We have, this is going to be minus. Okay, it's going to be minus. So what is the value? Time is up. So this is the last. Okay, we shall continue from this one. So what is the value? So the value are the limitation. Okay, for the first question we have 2, 1. Okay. For the first question we have 2. For the second equation we have 1. For the third we have a 3. For the fourth we have what? 2. Because it has converted into 2. Okay, this is the value which we have. All right. So once you've done this one, what do? You find the ZJ. What is the value for ZJ? ZJ, for those who are in the class, as you remember, okay, is ZJ is equal to what? ZJ is equal to the sum of CBJ into A. Let me write here. ZJ the ZJ is equal to the sum of CBJ into AIJ. Okay. See the value of CBJ 0 into AI into, I draw like this so you can understand. This one, okay, means 0 into 1 plus what? 0 into 1 again, 0 into 1 plus, again this plus, 0 into 0, okay, 0 into 0, 0 into 0. So you're going to multiply for every column. So it is going to give us a 0. For initial, all becomes 0. Okay? We have our 4 zeros. Is it 4 or 5? 1, 2, 3, 4, 5. They become 6, eh? Yeah. Because we have 6 constraints. Good. I mean 6 lines, 6 variables. These are the zeros. Now, you find the CJ minus ZJ. You're going to take the CJ, you will do it, CJ minus CJ. And then you find the maximum, and that maximum will be what? Will be the pivot column or key column. Okay? Key column. And then you proceed. So for the next class, we shall proceed. The main point was to explain or to show you how these variables are added. Okay? How these variables are added. I hope you understood. If you don't understand, you can ask me a question before I end this session. All right. So if there is no question, then let me wish you to have a good day till we meet the next class.